and homeowners in general about what Passive House is and why they should know about it. We had seminars all over the province, everywhere from Grand Prairie to Lethbridge and a host of cities in between. We went up to Canmore, Edmonton, Red Deer, and we will soon be posting equivalent courses online as well. We recorded some of those sessions. So then you can sign up as a member of Passive House Alberta. We have our website there, passivehousealberta.com. And you can sign up as a member there and you can get access to those courses once they're available. Should be in the next month or so based on the information I'm hearing from our board meetings. This is me, Stephen Cox. I'm an EA, so an energy advisor registered with Natural Resources Canada. That's what I do most of my work in these days, as opposed to the Certified Passive House Consulting part of it. That is with the PHI Institute in Germany as well, not the FIAS Passive House idea. Everything we're going to be talking about today is going to be based on the PHI building standard that's most widely accepted globally. I got my Passive House certification in 2017. It's quite a process of itself. The exam is you can't finish the exam. They give you 3 hours and it's an 80-page exam and they don't expect you to finish it. But it's quite an event, which is another presentation if you wanted to go through that. I've been working with the VT group of companies for a couple of years now. I spend most of my time doing residential work. So I do energy evaluations on existing houses, 936 code compliance for new build houses. And then we do building investigations as well. So most of my time is spent under Vertitech Energy Management, which is a brand you may have heard of, and then Qualistat, building performance consultants as well. So that's where we spend most of my time. This past September, I moved into the role of vice chair at Passive House Alberta, as we did a shuffle to accommodate that education grant that we got from EEA. Before that, I was a secretary, and so I've been with Passive House Alberta from the start, and we're going from there. For the rest of our time together this afternoon, we'll be going over these agenda points. I did say that Passive House is not high tech, but it is very detailed. There's a lot to go over, even in an introductory session such as this.
What is that?
So we're going to cover over why Passive House is so great, the 5 principles.
Stephen, just a second. I don't have the ability to unmute all now, or sorry, mute all. Could you please do that on your end?
Let me get over there. Such as this. Looks like. I can't hear Sol tell me it's not working. So it looks like it's working from what I can see. Okay, fantastic. So I'll go over this part again in case that was interrupted. For the rest of our time together, this afternoon we'll be going over these agenda points. I did say that Passive House is not high tech, but it is very detailed. There's a lot to go over, even in an introductory section such as this one. And considering our audience of engineers, then you guys are going to want more than just a high-level gloss over for what Passive House is. So there's going to be a couple of slides about numbers and performance data in here. So for those of you who like that, hold on to your hat. That's going to be thrilling. So in case some of you don't know, what is Passive House? Passive House is a performance-based standard that can apply to both new construction and renovations of buildings. There are many different levels of certification of Passive House that the Passive House Institute can administer to a project based on how it's built, and we'll cover those later on. One thing that I really like about Passive House is the chat there. I think the slides are available, I believe. I did send them to be a PDF, so they should be available. One thing that I do like about Passive House is that there's no prescriptive way that it needs to be completed for a project to achieve certification. It's all about performance. It is possible for a project to be constructed using no PHI certified materials and still get certified as a Passive House project. With other building systems, that's not the case. You have to use how the system's laid out. Passive House is based on proven performance. There's a Passive House that was built one of the first passive house brand passive houses that was built to this passive house standard by Dr. Wolfgang Feist in Germany. He went on to create the Passive House Institute in Germany. The house was constructed in the 1990s. In 2010, it was stripped down and torn right apart just to see how the envelope was performing. They had no issues of any materials deteriorating. They wanted to make sure that inside the envelope was performing as it was expected to over this period of time. And all the materials that were removed from the building were in exactly the condition they were in when they were originally installed. There was no deterioration. So that speaks to the performance of the envelope of one of these passive house projects. The first solar passive house was actually built in Saskatchewan in 1988. And that's where Dr. Feist got his idea for the passive house as we've come to know it today. Passive house, certified passive house buildings now account for more than 107 million square feet of developed building space in over 40 countries around the globe. And this is in all types of different climates. This is in cold climates like Alberta. This is in moderate climates. They call it temperate climates in Europe. And this is in warm climates. We're talking California. We're talking in Asia. It's quite big in China right now. China's making a big push towards passive house in a lot of their larger buildings. And it also spans all kinds of different buildings. It's not just houses. It's typical for passive house to require up to 90% less energy for heating and cooling, depending on the climate, than a new build code house. Passive house is also the minimum building code in places like in Europe, in Brussels, and in Austria. Some cities in North America are also embracing passive house. These are going to be cities that are more vertical built than horizontal built, so less sprawl like Calgary has, where I'm speaking to you from now, if that wasn't clear already. We have lots of single family, but places like Vancouver and New York, where they build in apartments that are more vertical, the math works out a lot easier for passive house, and it's simpler to get a certified passive house building in a multi-unit construction than it is in a single detached construction. So since it's launch hour, I thought I'd put in this pie chart for you, showing the average energy consumption of average homes. When we talk about energy savings in a passive house, we're talking about the largest piece of the pie here. That's that 60% piece, that heating piece. Passive house will reduce the size of that piece of pie by up to 90%. That does change your energy bill. Does that change your energy bills by 90%? No, but that's a different presentation entirely. Certainly a conversation worth having, but you're the energy engineer, so I'm sure you know all about that and the way that utilities are charged in this problem. What are the components of a passive house? We need to heat the house. We need to heat the house by only consuming 15 kilowatt hours per square meter per year of energy, which is about 90% below the Canadian average. This also needs to have an overall airtight, passive house also needs to have an overall airtightness rating of no more than 0.6 ACH at 50 Pascal pressure. We need to consider, we also need to consider the overall comfort of the home to be in line with ASHRAE criteria. So you guys are well familiar with those criteria when it comes to comfort and air changes. We need to make sure that there's we are not overheating the home any more than 5% of the time. And this is actually a bigger problem in Calgary because we have such warm falls typically. Overheating a home is considered any time that the indoor temperature is over 25 degrees Celsius. So this is a challenge in Alberta, especially in Calgary, because in September, the sun is low in the afternoons and evenings, so it's usually below the solar shading that we build into our passive houses, but it's still quite hot. So it can really drive solar heat gains up on west-facing and southwest-facing windows. Finally, the primary energy demand needs to be less than 120 kilowatt hours per square meter per year, which includes the hot water, space heating and cooling, and all lighting and appliances consumed. What is primary energy? Well, I have a slide for that, and that's this one. So primary energy is the total energy demand from non-renewable resources that is supplied to the building. You can kind of think of this as cradle to grave perspective in terms of energy consumption, which starts at the point where the energy is created and ends where it is finally consumed at the home by turning on the light or being turned into a unit of heat to warm the home. In Alberta, this calculation works against us when passive house calculations, because we use so much of our energy is generated on non-renewable resources. We mainly use electricity now that coal is phasing out. And again, comparing Calgary to Vancouver, large amounts of energy that are supplied to projects in the Vancouver area are powered by hydro, so largely renewable, which is a benefit to passive house projects during the when you do the PHPP calculation. Passive house is considered to be the most rigorous voluntary energy-based standard in the design and construction industry today. That kind of goes back to one of the reasons why we should be starting with it on our new build, and what drew me to this system of building. You may as well start with the best place to start with and then finish off with everything else after. So Steve, these houses, you may say, these houses are getting energy efficient and they care about where they get their energy from. But if I were to live in one, what would make it so great? I'm not sure where my text is on that one. Oh, it's animated, fantastic. Passive houses, on top of consuming very little energy in the home, is also one of the most comfortable environments you can occupy. It's quiet, it's not drafty because it has fantastic air quality, and it has fantastic air quality due to the continuous running HRV, which is highly efficient and very quiet. As mentioned earlier, these are very durable buildings. They have very low life cycle costs. So this is a conversation that can be had when an interested party is building and maintaining their building. For the situations where they have only builders who are just turning out buildings and then they're turning the maintenance of that property over, or they have a different maintenance department for the property, this conversation can sometimes fall on deaf ears. They don't, just get all those in there. They don't see that full benefit as just a turnkey builder. They won't see the full benefit of building a durable building. They'll just see the upfront cost of building a high performance building. But having a discussion about the life cycle costs and helping people see the full cost of a project is another rule for passive house. When we're using the PHPP, you'll get a predictable result for planning from planning stage through occupancy of the house. Passive house will also apply to new builds and renovations as it applies to all kinds of buildings, not just houses. Around the world, there are passive house grocery stores, certified grocery stores, hospitals, schools, and then just in Alberta, we have a certified town hall, which we'll go through in a couple of slides, and a car dealership as well, which is unique in North America for sure, if not globally. They're both certified passive house structures. I'll be looking at those in short order. So here are the 5 principles. These are the pillars of passive house, the foundation by which this style of building is grounded on. We've talked about some of the more technical requirements already, but here's the important points for the whole building. Now, I usually reference these points when I start a conversation about passive house with someone. Here, I can even give you the back of a napkin explanation that I give to somebody when the topic of passive house comes up. When does passive house come up? Typically, people will ask why I'm in building, why I'm in the building industry, how did I get to where I am? And so that's, passive house is really a stepping stone for me. So that's where the conversation comes up. But when I get asked about passive house, what I tell people is that it's a super insulated, airtight building that you can heat with a hairdryer. That's it. I can usually tell right away if they really understood what I said, if they really understood the impact of what I said, and if they're interested in a further conversation at that point. You might ask, how insulated is super insulated? Well, there's no hard and fast rule for passive house, as it is performance based on the home's performance. But talking about rough R values, looking at about probably an R40 in the wall or more, and then R60 in the roof, in the attic space, as well as substantial under slab insulation, depending on if we're going with a basement, if we're going with a slab on grade finish. There's a whole bunch of stuff there. It's not uncommon for a wall system to be 16 inches thick or thicker in Alberta if we're trying to achieve a passive house standard. We touched on air tightness already, so we don't need to cover that again, but air tightness is 0.6 ACH. And to give you a reference, the building code in Alberta right now says we're building to a 2.5 ACH air change with our batten poly typical drywall applications that we're doing. Passive house is also thermal bridge free, which means that we need to be conscious about all the thermal bridges we have in our house, whether that's window penetrations, whether that's a deck penetration, whether that's corners, how we're framing our corners, floors, where they meet the exterior, all that. So what you can think about it is it's impossible to have a thermal bridge free building, virtually impossible. So what you have is you have a thermal bridge budget that you can use for when you build your building. And there's a couple of slides coming up that will illustrate that as well. Passive houses, as you might expect, need to be conscious about the number of windows in the building. So, and which way they're facing and how they are shaded. We touched on this already a bit earlier. With a passive house, the sun is your main source of heat. So you want to make sure you are capturing all your solar gains in the winter when you need them, and you are shading the home from those solar radiations in the summer when you don't want the heat, when you're at risk of overheating the space. Finally, a very important part of passive house is to have a continuously running HRV. This is not a North American HRV where it runs 20 minutes out of every hour just to make another fan run in the house while recovering 40, 50% of the latent heat. These HRVs are third-party tested by the Passive House Institute and verified as being 90% or more efficient at recovering latent heat from exhausted air. There are a couple of manufacturers in North America that build PHI certified HRVs, but not many. You're not going to find them at the hardware store. They're very particularly modeled. And typically you run most of this is your heat distribution system. Instead of running ductwork off of a furnace, we're running ducts into every room with our HRV to exhaust the conditioned air and to pick up stale air, depending on the room. So this year we have some thermal images of different insulation techniques. So the project on the left is a conventional construction. You can see that, I'm sure you guys have seen thermal images before, but there's a distinct gradient there where there's heat loss through the wall system. The image on the right is the Passive House project. You can see that there's no thermal bridging. The only cold spots are the windows, which they're windows, so there's only so much we can do about that. But the wall system itself is uniform in color, which you're not going to see in North America. There's always thermal bridging. In any project that I go to, you can always see some form of thermal bridging through that envelope. These are some images of air sealing in a completed passive house. As passive house assemblies are so much thicker than conventional buildings, the air barrier and the vapor barrier are not usually in the same layer as they are in Alberta with our poly construction. One of the fellows that I met through Passive House Alberta said of the poly system, it doesn't matter how you dress it up, you're still living in a plastic bag. And that speaks to both the air tightness of poly-built houses as well as their resistance to vapor permeability. So a passive house is going to have an airtight layer, like we can see on these slides here. That's an OSB used as our airtight layer with airtight tape. So that's not tuck tape, that's not tin tape, that's a specified airtight tape. It's manufactured in Switzerland. This particular one is, and it's designed for this application, for being airtight permanently. So that allows us to have an OSB as our airtight layer. And then we manage the vapor through the passive house wall system by keeping the assembly vapor open. We have vapor retarder layers. So that's going to get us through our code inspection. But vapor can still transfer through the entire wall system if it accumulates for whatever reason, for rain ingress or for condensation, for pressure buildup, any of that. But this is just one way of doing it. I know there's a builder up in Edmonton who builds very close to passive houses, and he does batten poly. That's just what he's found to be economical for him. And like I said before, there's no hard and fast rules for passive house. You don't have to do OSB air barriers. There's smart air barriers that are on the market now. Different manufacturers are coming up with breathable air barriers that change their vapor permeability based on the level of humidity on either side of the barrier. So when we're talking about thermal bridge-free design, we may be thinking that we're going to have to sacrifice some of our cantilevers, some of our deck details. Well, we don't need to sacrifice them. We just need to be more conscious about how we tie them into the building. So here you can see a thermal bridge-free deck cantilever. The beams do not carry through the house. They are surface mounted, which I think most of the ones that we do these days are in Alberta. But this significantly reduces the thermal characteristics, the thermal bridge characteristics of this design. In the old days, we would have had beams cantilever all the way through the building just to carry these decks and just bleed heat right through them. Heat and air usually. Nope, that's not what we want to do. Here we are. This is a typical slab prep for a passive house. You see large amounts of EPS foam. That's probably 8 to 10 inches of EPS foam under the slab, and then 4 to 6 around the rim of the slab. So this is going to be probably a slab on grade application with this particular one. But that reduces their thermal heat losses through the concrete, because concrete is great at conducting heat, almost as good as metal. So we need to retain as much of that as possible. And we can steal some of this for when we have basement condensation issues in new build houses. If we did exterior insulation, we'd be using the thermal mass of the foundation wall instead of making those walls cold and bringing the thermal barrier to the inside of the basement. If we made the thermal barrier on the outside of the foundation wall, we'd make our basements a whole lot more comfortable. But we'll do that one conversation at a time. This again touches on the windows orientation and how we need to protect them from the sun while trying to maximize the sun in the wintertime. So the yellow lines on the diagram on the right there are going to show the solar heat gains in the wintertime when the sun is low on the horizon. And the red lines show the solar radiation in the summer. And you can see how it's interacting with the shading features. So in Alberta, we need to be conscious about where we're shading. And when we're doing passive house, especially, we need to be conscious about how we're shading, how much we're shading, where our shading is going to be, and how that's going to impact our total heat gains, because that is our furnace. And if we shade too much of our window, we're not going to heat it when we need the heat. Mechanical ventilation, like I said, is a very important part of passive house. The HRVs that run in passive houses are almost silent as well. Typically you can't hear them running when you're standing beside them. But living in an airtight house requires you to have a source of fresh air. In passive house, that source comes from an HRV. In Alberta, you could make the case that we should do ERVs. I'm not entirely convinced of that, but I'm just a consultant. But that'll depend also on your client, what they want to do. So I'm sure you guys all know how HRVs work. They condition the incoming air by extracting the latent heat from the exhausted air that's leaving the building. That was going to be wasted heat anyways. Okay. So passive house in relation to other green building systems. Passive house is one of the only building standards that is only focused on energy consumption. It's my own belief, as I've stated a couple of times already, is that all green buildings, high performance building standards, should start at passive house. The goal for the 2050 building code in Canada is to have all new buildings be net zero ready, which in definition is a passive house. If we have a building with 15 kilowatt hours per square meter per year of energy demand, you throw a solar array on that and you're net zero. It's very simple to reach net zero energy consumption when we start with a passive house. I can remember taking a lead course and the instructor told me in very clear terms that any project that we put solar panels on becomes more efficient. And I had to disagree, and this is one of the reasons that I didn't continue with my lead education, is because it doesn't make the house more efficient. If we put solar panels on a project, it doesn't make the project more efficient. It makes the generation of the energy more efficient, but it's still going to consume the same amount of energy, regardless if there's solar panels or not. So it's just a change of focus over some of the bigger points-based programs. If you start with an airtight envelope, then also speaking to the VOCs bit in lead, if you start with an airtight envelope, you're going to be more conscious about the products and finishes you are going to use to outfit that home with. There are going to be lower VOCs if you build an airtight house. And if they aren't lower VOCs in the first house, then they will be lower VOCs in the second house. After you get your reviews or you live in the space or what have you, and you see what kind of impact having a high performance envelope will give you. So these are the certification levels for Passive House. We have these are all, like I said earlier, these are all from the Passive House Institute in Germany. So there's Passive House Classic, which is what we've talked about mostly so far. And the bare bones of these programs are just about the same. The next level up is Passive House Plus, which is net zero. It generates the same amount of energy that it consumes. And then there's Passive House Premium, which is net positive. And probably if you look hard enough and you get the ire of the wrong inspector, probably is not yet allowed in Alberta. I think we're only allowed to generate as much as we consume at this point, but that's another presentation. Passive House also does certifications for renovation. So these are called EnerFit, and they use the PH instead of the F for fit. And they have slightly less stringent energy consumption and air tightness requirements. So instead of it being a 0.6 ACH, they let you be a 0.1 ACH on renovation. And instead of being 15 kilowatt hours per square meter per year, it's 25 kilowatt hours per square meter a year, just because they acknowledge that there is some extra challenges that you have when you're working with a renovation. If you're doing a true renovation, if you're tearing it down, ripping it out, and then throwing in a new one, then you're not going to have, then it would fall under a new build project. And finally, they have certification for buildings that meet the heating load requirements, but don't have the performance or the solar heat gain potential, and that would be a registered low energy building. So if you think about building a passive house in a valley or some such, there's both. If you think about building passive house in a valley where you don't have solar heat gains, in the mountains where there's sometimes inconsistent solar heat gains, then low energy building may be the option for you to pursue. So now I'll take you on a quick tour of some passive house projects all over the project, not all over the province. Not all of these buildings are certified, but I will mention the ones that I know are. So this is the Town Hall project. Our first stop in the Tower of Alberta is the North American first. So this is the Valley View Town Hall project, which recently received Passive House Plus. This was the first institutional building in North America to get this certification. The lead architect for this project is the board chair of Passive House Alberta and is indirectly the reason why I'm sitting with you now giving you this presentation. Fletchis, or Oscar Fletchis of Fletchis Architecture, if you're looking for somebody to do some architecture work. So this was his project, his baby, and it just in the last 2 months, received certification from THI in Germany that it is Passive House Plus certified. And as far as we are aware, it's the only one in North America, the only institutional building in North America that is Passive House Plus certified. Certainly, and likely the first one. Certainly in Canada it is. Here are specs for the insulation value of the building, and when you combine that with the 0.37 ACH, it reaches the Passive House Plus level with only a small amount of solar arrays. The way that Valley View applied for this is they got a grant to help them. So the town of Valley View applied for a grant to help get the building constructed. The grant ended up covering the upcharge to get the Passive House certification, level of construction. This is a good kind of program for governments to be involved in, because what it does is it gets better buildings built that were already being planned, and they don't need to charge. They don't need to pay for the whole building. They just need to pay for the upcharge to get it to something like a passive house. And another reason that a government program may want to look at going with incentivizing passive house is that it's third-party certified for performance as well. This is the first, as far as I'm aware, this project is the only certified car dealership in North America, maybe even the globe. I was fortunate enough to be on the team which conducted the final air test on this project, and that was lots of fun. Some other large projects like these in North America do exist, and they are Passive House certified, like assembly lines or warehouses. But what they do is they only get the office building certified, the place where it's going to be occupied by the administration certified. This particular project is fully certified from one door to another, from the sales space to the office space to the garage. The entire building is certified Passive House. It has airtight overhead doors that lock and lock airtight. So, and they got ordered out of Switzerland, I believe. In order to know how tight and how warm they needed to make this building, they had to calculate how often the overhead doors open in the bays, whether to let cars in, to let cars out, to move stock around. And they needed to calculate how much heat was going to be lost every time that those doors opened. Most certified building materials for projects like these do come from Europe. There's very little North American built that's to this standard, especially in cold climate applications like Alberta. There is some Passive House certified materials coming onto the market, but those are more for mainland Vancouver. So it's much easier to retain heat in those climates. This home was entirely constructed by the homeowner and his father using a Zoom boom in just a couple of days. They built this house using CLTs, which is cross-laminated timbers. So if you don't know what cross-laminated timbers are, think of a wall, a uniform wall made out of 2x8. So the 2x8s are glued together on the flat, and so they turn then they router out windows, and so that you have one big wall section that you just put in place and then lock it in with the next wall section and the next wall section. So it's a time-saving one if you're not a framer. And it also gives you a really unique atmosphere if you leave the CLT unfinished on the inside, because it's exposed wood kind of look. It's really rustic. I toured this house when it was during construction. This home is off-grid and has a large amount of battery storage that you can see out the back in the garage in the top image there. They went all out on the solar panels to generate enough battery energy to power the shop, because that is a workshop and garage in the back. If memory serves, this gentleman is an electrician by trade, so that may explain some of the thought process there, but entirely off-grid project. This is a really interesting one, and it's self-built too. So you don't even have to have all of the answers, and you don't have to have all of the certified tradespeople. If you do it the right way, you can do it yourself. This is last stop on our tour. Takes us to the community of Montgomery in Calgary. We'll talk about this home a little bit as well. This home is lived in by the designer and his family on the main floor, and then they developed the basement into a secondary suite, which they rent out. If memory serves, this house is a double 2x6 wall with an extra row of insulation in between for thermal bridging. And then this one, I think, also has a 2x2 installation cavity in front of the front row of 2x6s to run your electrical through, so you're not running wires through the envelope everywhere. This home is a good example of what can be added to a passive house project as well to improve the impact on the environment of the house. They have permaculture food forest on the property, and then they also have rainwater harvesting for irrigation. Neither of these are considered when you're going for passive house certification. Passive house is only worried about the passive house. What you do with the rest of the property is up to you, but generally people who are concerned about passive houses are interested in other things that they can do. Rainwater harvesting, food forest, solar energy. So that can be included with the homeowner if you're doing the whole project. So when we're talking about, so this slide tells us about the total energy use for that Montgomery passive house. The gentleman who owns that house was also a founding member of Passive House Alberta, so there's lots of data we have about that house. So the PHPP estimate, PHPP is the software package that we use in Passive House to calculate the energy consumption that a home is going to have after it's built. So the PHPP estimate was 16.8 megawatts per hour per year, megawatt hours per year, sorry. And the actual 17 megawatt hours per year. I compare that to the average Alberta house, which is 40.5 megawatt hours per year. And then we go through he has $1,000 of gas costs, utility bill on his utility bill, and $500 of that is fixed costs. So that speaks again to that transmission of how you can use less energy, but it doesn't always cost you proportionately less money. And the duplex home still consumes less than 50% of the energy of a single family home. He lists his EnerGuide rating here. For those of you playing the home game, EnerGuide is a different system now, but suffice it to say that a 61 is a good value. We want to be closer to 0 on that one. Okay. So passive house costs, as mentioned before, there are added costs to building better, but there are extra added savings and other soft benefits to owning and living in a passive house. Some of the cost increases will decrease as components are built in North America. Right now, there is cost associated with shipping lots of materials over from Europe, whether they be windows or HRVs or CLTs for that matter. We do have the ability to make all of these things in Canada, in Alberta, in North America. But there isn't the demand for them yet. So those of us in the passive house world are still pulling most of these materials from Europe. Typically, when we're talking about passive houses with a client, what we do is we say that the initial build cost is roughly 10% more than the code built house. Just if you start out planning for a passive house, there are efficiencies you can work into your passive house project, and then as builders in Alberta get more experienced with passive house and high performance buildings, that cost is going to come down. The cost adder is going to come down. Also, as we get more builders into the market, then we have our supply demand curves. Okay. For design optimization, we want to make passive house footprints as efficient as possible. So the house on the left is a lot easier to make into a passive house than the house on the right. That's something that North Americans are going to struggle a little bit with, especially people in Calgary, is building passive houses and not building North American style houses passive. It's a lot harder to build a North American style house passive. When we have vaulted ceilings, when we have bonus rooms, when we have cantilevers, if we just go with a rectangular building and that rectangular envelope, it's a lot easier to seal. There's less thermal bridge potential. It also reduces your air leakages, right? If it's a simpler building, there's less opportunity for an air leak to go unnoticed. Okay, so now new energy codes are helping bring up the baseline, but what we can see here is we're comparing the passive house standard to the NECB 2017, which is what we're using now for energy code. So we're looking at 2.5 air changes per hour versus 0.6 ACH, effective R value of our 40 in the walls versus our 22 for standard construction. Window R value, we're looking at R7 in a passive house or greater, and then we're looking at maybe half of that in a conventional house. And HRVs aren't mandatory in the new energy code. They're a good idea, but they're not mandatory. Another challenge that we're having with passive house is permitting and policies. As I'm sure you guys know, as soon as we do something different than what is expected by the inspector, you have to go through a whole lot of hurdles. So something that we're pushing for is to adopt PH3P as modeling software, as energy compliance software. Right now, only HOT 2000 works. So we need to get, so there's a group in Ontario, I think, that's trying to get PH3P registered with ASHRAE to show compliance with those. But then it's also with municipalities, and the inspectors that go out there to inspect these things need to know what to expect, and they need to know that even though this is different, this isn't worse. This is much, much better. We're running tight on time, so what I'm going to do is I'm going to skip over this one. So I just say that there are CMHC benefits out there for building greener homes, and they result in rebates typically on the mortgage insurance part of the application. Final piece on greenhouse gas emissions. If a passive house becomes a building code in Alberta for all new homes built, we could save 150,000 tons of CO2 per year. Each house built to the passive house standard saves 6 tons of CO2 emissions per year compared to the standard house. So this comes from if we build over 25,000 new homes in Alberta every year. Okay, and then I'll leave you with this piece here. Each building allowed to be constructed at a suboptimal efficiency is a 50+ year liability in a world that needs to be almost fully decarbonized within 30 years. That comes from our friends at Pembina. So when we build passive house, we are solving, if we can build to passive house, we're solving a third of the energy consumption issues that we're having right now. And that's soon on our horizons. So I'll take your questions. If Sol has anything else, I left her, she asked me for 1 minute, so I left her 7. So that should work for that. I guess I need to redirect this back to.
No, actually, Steve, you can just leave it there because Steve,
yeah.
you might need the slides to answer questions.
Slides?
So,
okay.
yeah, let's just have. I mean, I don't need to be the host anymore. I will just say by this way. Anyway, so yeah, we can take the questions, either raise hand or type it up,
okay.
or just.
So I see one here. I see one here from CB, whoever CB is. Hello, CB. We do have some data on. Sorry, let me try doing it this way. We do have some data on the cost per square foot, but I don't think I have it in comparison to. So this here, yes, you should see it. Okay, so the cost. For the Montgomery Passive House, the one in Calgary, we had a cost of $340 per square foot, and that's above grade. And then when you account for the developing the basement, that brought down our average cost to $200 per square foot, which is, if I remember correctly, is not too far off of our average cost for square foot for conventional building.
Mm-hmm. Someone is asking, Ali is asking the typical payback period for passive house construction. Do you have some calculation?
So payback period is certainly a conversation worth having. The PHPP package does talk about energy savings and the dollars saved in energy. Right now, I'm not going to sugarcoat anything. Right now in Alberta, the payback period for building a passive house is probably in the neighborhood of 50, 60, 80 years. That's because we do most of our heating with gas, and gas is dirt cheap. If we were doing it with electricity, it would be, we'd probably be seeing our paybacks in 10 to 15 years. But it is, right now, the only people who are going to see a cost benefit savings over the lifetime of their project are people who are going to be owning and living in that project for a very long term. And so this is your new family. This isn't your grandparents that you're moving in that are going to be looking to sell in the next 10 years. This is the people who are going to be interested in that are your yuppies. The young people who are starting a family, who have yet to start a family, but they're setting in roots in this community. And if we can build these houses to be age in place, then these people are going to see benefits. And then let alone their house is already new building code ready when it comes on the market to sell when they are done with the house. It will be a high performance building then and performing well as well.
And unless having it off grid, then you can't even save on all the fixed costs that come with your utilities. So,
exactly. Yep. Mm-hmm. Yep. That's a jump that lots of people can't make. But yeah, if you can make that jump to being straight off grid, then you'll get your paybacks faster.
We had a question about whether there is a commissioning procedure or not.
The calculations are typically done by the consultants, the designers, and then verified on site. There certainly could be more extensive commissioning done, but there's not as much focus on commissioning as there is in a LEED project. Mm-hmm. Commissioning is huge for LEED. So mm-hmm. there is a calculation and a result that needs to be accounted for when we're doing passive house buildings, but there's not a commissioning stage typically.
If I remember it correctly, there is a passive house reviewer, which is apart from the consultant. So I guess that's the job passive house reviewer has.
Yeah, so the passive house reviewer is typically just reviewing the data. So that's a certifier is what you're talking about.
Yeah.
So on a project we have, I'll just go through this for everybody else, but what we have is we have the design team. The consultant designer is going to be, the passive house consultant or designer is going to be a part of that team. And they're also going to be involved in the construction, talking with trades. And then as an extra layer of certification, we have a certifier who reviews all of the work that's submitted by the consultant designer before it gets sent over to Germany for final certification. Mm-hmm. So that's the role of a certifier, but they don't do the actual commissioning.
Mm-hmm. There was a question about the building material. This is actually a really good question. They want to know if you can use, say, timber frame, conventional, or is there any specification for material? Can they go with that conventional ways, or can they use ICFs?
Yeah. So the short answer is yes, you can. You can get to, however, Passive House doesn't care about what you use to get to the energy consumption. They care that you get to the energy consumption. ICF is a fantastic option if you like that kind of thing. I'm personally against it, but I have no grounds for that. It's just something weird with my mind. It's airtight. You've got your thermal mass. All of the houses I've shown you on the tour are all wood construction of some kind. There's nothing saying that you can't do timber frame. You just have to be extra careful because you have so many penetrations coming through. It's not nearly as neat and tidy as other designs. But yes, however you want to build your house, however the client wants to build their house, however whatever's available is welcome in Passive House.
So isn't it necessarily, doesn't it have to be Passive House certified for material? Do we not have such thing?
No, if we look at the house that's on the screen right now, this house was framed with 2x6s that you get at the hardware store. It was insulated with rock wool insulation that you get at the hardware store, and sheeted with drywall that you get at the hardware store. None of that is certified.
Not even windows or doors?
The windows, all except for one door, maybe two doors on this one are certified, but the bulk of the construction materials don't need to be certified. Just the HRV, the windows, and the doors. And they don't even need to be certified. They can be whatever you want them to be, but it makes certification a lot faster if you use certified material.
You did sort of answer this question, but someone is asking about Passive House in areas like the Middle East with huge cooling loads and how it is recommended and basically.
So if you can take all of the principles that we've talked about in this, except instead of orienting our building to the south and to maximize our solar heat gain, what we're going to do is we're going to orient our windows to the north to maximize our cooling load and to reduce our heat gains from the hot sun. So yes, but Passive House is you just have to tweak its orientation based on where you are on the globe. But certainly you can do Passive House in the Middle East, absolutely.
You mentioned there's a certification for existing buildings. Someone is asking if there has been this attempt and if you have experienced the retrofit an existing building into a Passive House building.
There have been retrofits done. I know there's a system out in England, I think, or Holland, where they mass produce Enerfit. What they do is they mass produce building envelopes that you just slap on top of the building that's there now, and then they claim that that's going to work. I am not aware of any Enerfit projects that have been certified in Alberta at this time. Yeah, I'll leave it there. Anything else is speculation.
Well, we are actually done in terms of time. I don't want to be too far over time. Just if you could briefly answer this question. Someone's asking if there is any other software other than PHPP for Passive House, which I think the answer is no. But cover that if there is another software and what the name of that software is.
Okay, so yeah, if you're doing Passive House, you need to use PHPP, period. Okay. There is a visualization plugin for, what's it called, SketchUp, for Google SketchUp. So you can do your drawing in SketchUp, and then what it does is it takes all that data and it slides it into the PHPP package much more efficiently. So you only have to tweak it a little bit instead of entering everything in hard as if you're drawing in CAD or something. But everything Passive House, if you're going certified, does need to be in PHPP.
Okay, perfect. Thank you so much, Steve, for your time, and thanks everyone for joining in. I have the email address for AEE Alberta chapter in the chat box, so please send us your feedback. We would like to hear from you, and also again, stay tuned, sign up for our newsletter, and we'll send you interesting stuff. Thank you, everybody. And the presentation would be available, I believe, to our subscribers, but I will talk with the team and confirm how we are going to provide it, but it will be available in the next week or so. Thank you, everyone, and have a great day.